So step one is to master the C language. C language is the number one thing that people should focus on. So DeepSeek engineers managed to squeeze the juice out of old NVIDIA GPUs just because they skipped a lot of frameworks. What the seniors usually expect is, so if we can convey to you a problem and you understand how to approach it in, let's say, C, C++, or Rust, then you're going to be useful to the team. So DeepSeek was created by a company that is actually a finance company. Their incentive is that you have to do trading in milliseconds. So they are used to writing performance softwares. And what they did was, with their skill of programming the hardware correctly, they ended up programming the old GPUs. And the result is that you have pretty good training.
Hi Pius, welcome back to our channel. So last time we had recorded a video and that video received really good impression and lots of people requested in the comment section that we should have more session like this. As you can see, there are very less resource especially related to embedded system and that you are filling out this void. So welcome back to this channel. So today's topic is how AI influencing the embedded system domain. Like you can see everywhere AI, and this is really booming topic right now. So today's topic is how AI is influencing the embedded system domain. So Pius, what is your view on this?
Well, in general, what I would say is the influence is very deep and very heavy. It's just not visible to the general public and students as much. Well, the electronic students maybe, because they tend to stay connected with the field and try to explore. But definitely, in the background, AI is kind of very heavily influencing the embedded world. When we talk about the effect or impact of AI on the embedded space, it's not as much visible to the general public. AI bells and whistles, the impact of it, visual impact of it can be seen at the app level a lot more. At the embedded level, if you think about, robotics, Tesla cars, then Tesla has this Optimus robot now. Then Boston Dynamics has their robots. So all of these things are also using AI, right? And well, talking about the latest example, DeepSeek, right? So DeepSeek, they could do as many optimizations and kind of, train a better, or rather make their model better than open AI. That was because someone was using the hardware correctly. So, that's the kind of effect it has, which is more from usage and consumption standpoint. And yeah, it's not readily seen by the general public.
So in the recent last 2 years, we have seen very good progress in the software side of AI, talking about like OpenAI, ChatGPT and Gemini. So that is more towards the software side. We have not seen, at least in the consumer side, we have not seen much progress in the robotics kind of AI. Like the robotics, they have, like the Tesla recently demoed one robotics. So that is just a demo. Like I'm not seeing much things like a robot who can do my household chores and all. So we are looking for this kind of robot, not the robot who is taking our job. So what is your
True.
view on this?
Fair. So, okay, I have multiple thoughts here. So let's break it down. So first thing is, unlike software, the hardware and embedded development is a little slow, right? Just because there are circuits involved, there are processors involved. So it takes time for development. In fact, there are, sensors that are AI capable now. The doorbell camera that can detect faces. So those kind of applications are out there, but again, majorly software powered, contained within that camera, let's say. But what we should see going forward, like Optimus, for example, from Tesla was the example wherein, it's able to talk to people because of, the LLM parts. And also it's able to kind of mimic the human-like gesture and the control system of it. That is the embedded part. And long story short, what I would say is the embedded AI are in kind of works, right? So the machines that we expect in terms of AI, I'm hoping that, they'll come few years down the line, because production takes time. App or software is just copy paste, and that's easy to do. But hardware requires manufacturing. Yeah. So for those reasons, it's slow, but it'll hit the markets. And I'm saying because, Tesla's Optimus and so on and so forth, I think they are doing mass production of that. from what I gather. So yeah, that's the state.
So looking into this topic, I think there will be more job in embedded domain in the future.
Definitely, yes, that is true. That is true.
But if
That
you
is very true.
current job market, people are mostly preparing for the development, like full stack development kind of job. They are
Mm,
not looking
mm.
into the embedded side. So,
Yes.
like I can share this with my experience. I have seen lots of successful engineer at Silicon in the Google itself.
Mm,
So this
mhm.
embedded domain is also like gaining interaction. Like it might be possible
Yes,
that embedded will be the next full stack development. So people should read about this and people should be interview ready for embedded domain also.
that's
And
correct.
for this, like Pius have really nice course on that, and this is
Right.
really helpful. Like my husband is the embedded software engineer, and he have taken the
Okay.
his course, and he's really
Okay.
impressed with that. Yeah.
Nice, nice. So one of the things that and you're, by the way, precisely right about, embedded jobs and embedded market booming. In fact, the trouble in embedded world is you don't find the right engineer. Fresh grads are very difficult to hire just because they would have worked on, a lot of full stack website or back end side of things. I have come across very few applicants who kind of have something that is C or proper processor programming or lower level libraries, that kind of a thing, right? And talking about, the void, I think it's an awareness gap
Correct.
because, with respect to web development, there is ample, in fact, I would say there's too much awareness available, right? So it's easy for people to get started and follow along and, self-guide themselves, so to speak. But for embedded, there is not as much out there. And exactly that is the gap we are trying to fill. And if I may, so the portal that we are running or the venture that we are running, it's called Pajama Bra. Pajama Bro is how we read it. And our intention is to just share the insights at various different layers so that you can reason down from the transistor up to the AI, right? So that is how it is.
So, like another question just popped up in my mind. Like recently, you have said that how DeepSeek are able to train
Mm,
their model with such a less
mm.
cost because they have
Yes,
done some improvement in the embedded side. Because if you will see,
yes,
once the Chat GPT launched, that time Nvidia stock was skyrocketing due to this
yes,
because Nvidia is
yes.
totally a pure embedded company. If you will see, like
Correct.
customer
Yes.
side. So yeah, so you can see there are lots of impact embedded system putting on the AI, and in future there will be more improvement in the embedded
That.
system. Like I just want to understand how this silicon chips and
Hmm.
GPU are becoming more efficient to handle the AI. So can you share your insight on this?
Sure, sure. So first off, GPU is like a hardware that can do a lot of matrix operations, right? And if you take typically, if you take a neural network, it translates into matrix operations, right? Matrix multiplication and accumulations. So GPU is a suitable hardware. It's not the best, right? So companies like Apple, for example, they have developed their own, whatever neural engine or whatever they call it. And iPhone 16 and 17, not 17, 16 were sold from that standpoint, Apple Intelligence. Okay, what I'm getting to is people are starting to develop their own silicon solutions that can do matrix multiplications very fast. And, kind of NVIDIA right now or GPUs are right now filling in the gap, right? So DeepSeek engineers managed to kind of, squeeze the juice out of old NVIDIA GPUs just because they skipped a lot of frameworks, right? So instead of programming it in, let's say, at a Python level or um, uh, some language like that, Java or something like that, what they did was maybe they went down to the kernel level and programmed it in C++ or something like that. I'll give you a background. So DeepSeek was kind of created by a company that is actually a finance company, right? And then the people are asking questions like, hey, how can a finance company come and disrupt AI? You have to see it from a different lens, which is the finance guys, the coders there, their incentive is that you have to do trading in milliseconds. So they are used to writing performance softwares,
Right.
correct? So they actually write softwares that are way down close to the Linux kernel, for example, close to the operating system. It's like you get a packet from the Ethernet, take a judgment, and send like a buy or sell decision on the at that level. You don't have the liberty to run an app and then JavaScript on top of it, not happening. So these people had that background. And what they did was, with their skill of programming the hardware correctly, they ended up programming the old GPUs. And they did a pretty good job of it. And the result is that you have pretty good trained model. And this is, by the way, not a summary per se, but my read into how they are doing things, right? So yeah, this is one way in which embedded is kind of helping.
Yeah, so I have not think in this direction. Like this can be people are giving some
Yeah.
random comment like they have bought from black market and all, but this is the different perspective. Like yeah,
Yeah.
I have seen this. Like if you will see, you can simply type some code in the Python and you can
Hmm.
type the same code in the C++. There's a huge difference between the
Right.
performance of these two language. So yeah, like when it's come about the language, I have a
Hmm.
different question that is out of
Sure.
this topic. So,
Sure.
like I have seen my husband, he's struggling a lot with the compilation. Like if you will compile anything, liners that take 2 hours for a few seconds. Like in the 30
Right.
second, we can see ki what is the things we have done. Like even if I
Hmm.
will miss a semicolon or something, it will take hours to identify. So why there is
That's
a
correct.
problem like this exist in the embedded system?
So what happens there is you are going to compile your software. So compilation requires that your software be correct at the syntax level first, right? Versus things like JavaScript and Python, they're more like, interpreted language. So you can write your script, run it, and then it goes serially. So you don't get to see the error until the interpreter hits that line, which is error full, right? So that is one reason. Now, if you ask why does it take, hours to compile? Well, first of it depends machine to machine. For example, I have had scenarios where the Linux kernel compiles in like, maybe 15 to 30 minutes. Then if you do so on a Raspberry Pi, maybe it takes much longer, right? So it has to do with compute power of the machine you're compiling on. One of my managers who worked in Microsoft told me that the Office suite back in time, like, I don't recall like which time frame he was talking about now, but he said it takes anywhere between like 2 to 3 days to compile. Right? But
Really?
we don't get to know. Yeah, and then it comes in like a C DVD or it comes as 1.5 GB installer. But the thing there is, all of your software is already written, and now you're going to shoot for converting into it directly into machine code, right? And submit it to the processor and it runs. That compared to languages like JavaScript or Python, there is an interpreter constantly running, and your program cannot run faster than the interpreter, right? And the funny part is this now. So you have the, let's say, Linux kernel, and you have 10,000 processes ongoing, right? The windows are being shaded, the GUI is being there, then there is Google Meet, there is Zoom, and all of that. And in between all of that, there is Python running. So what it really means is Python virtual machine or what interpreter is running, and on top of that, you have your program, right? So if the CPU was, let's say, running around between 10 processes every 100 milliseconds, your Python program gets one slot in that 10, right? And that too, on top of it, it's running the interpreter, and then interpreter is running the program. So that's like the difference. Hopefully, I answered your main question, which is why
Yeah.
does it take so much time? It needs to be compiled. Yeah.
Yeah. So, like, my next question is since lots of our viewer are fresher also and a college
Hmm.
student, so how
Hmm.
they should prepare themselves for like this domain? If you will
Hmm.
see in the coming, like, at least what I understood, now, like, I am doing the front end role. So,
Yes.
in future, the front end
Hmm.
role will be replaced by AI heavily. Like, there
Okay.
will be one prompt engineer that will do work of 3 or 4 engineers.
Okay.
So, like if you will see this web development job will decrease, then there will be like more job in the AI domain. This is my
Hmm.
personal observation, like AI and
Right.
AI domain in the sense ki like AI integration with the robotics, AI integration with the different consumer facing
Right. Right.
application. Yeah. So
Right.
for that, like if you will see any consumer facing application, especially it's the hardware side, then there is lots
Mm.
of work related to C++, Linux, and kind
Right.
of thing. So can you share a
Right.
short roadmap for the college student
Sure.
how they should learn these things?
Okay. So step one is to master the C language and master the concepts. C language, I believe, is the simplest language. It only has 32 keywords. It's just that the way to learn that language is a little different. You have to first reason about how a CPU works and how the memory works, and then you can reason about the C language. That said, C language is the number one thing that people should focus on, right? That is one. Now, the second thing is in embedded, pretty much the entry level jobs are related to, driver writing, validation, then, QA or testing. These are like the three major domains that I know of. And firmware development and driver development being the primary, that definitely requires a handle on C language. What they can benefit out of is also exploring 32-bit processors, having some idea of how the CPU executes the code. That helps. Basics of operating system. And when I say basics of operating system, it's not like, dining philosopher's problem and all of that. Nobody cares about that anymore. Things that people care about in operating system is something called operating systems primitives. So if you have two threads talking to each other, what are the mechanisms the operating systems provide to you? Mutexes, semaphores, event queues, the threads, mutexes, so on and so forth. So those kind of things, if people spend time on understanding, how does this work? And instead of starting from Linux, in fact, one of the I believe, okay, and people might actually be very mad at me for this, but I believe if you start off your career straight up in Linux, in my opinion, it is bad for you because a lot of Linux is already written, and then you start off in a corner and your career stays in that corner. It's a struggle to go outside of. My recommendation would be instead of focusing on Linux as a thing to study, of course, you can do that on the side. No, no worries on that. What you can start off with is RTOSs, real-time operating systems. They're pretty small in size. Their source code is tiny and you can make sense out of it. So I would, and some of the RTOSs, for example, is free RTOS, little kernel, ThreadX. So those kind of things people can go after. Yeah, so those are my tips.
And what about the working professional? Like how they should like if
Mm,
someone is working in the embedded domain only and they want to enhance
mm.
their knowledge, then how they
Right.
can do that?
One thing I should have mentioned is from a fresher in the embedded world, what the seniors usually expect is that we be able to talk to them. And that's enough. If we can convey to you a problem and you understand how to approach it in, let's say, C, C++, or Rust, then you're going to be useful to the team. For a professional now, the game changes from they should know the C language and all of that, of course, some basics of it, but they have to now think at a system level. Let's talk about like a vacuum cleaner, an automatic vacuum cleaner in the like disk kind of thing, right? Robot. So it has a lot of sensors on it. It has a lot of actuators. Actuators are things like motors, right? Which kind of drive some mechanical movement. And sensors sense the environment. So senior person is supposed to be able to understand that given a processor and let's say some software running on it, free RTOS, for example, how are we going to sense and how are we going to act? Now, in terms of them wanting to upscale, they should be looking to go in the direction of design. What are the design patterns in embedded system? They should be focusing on that. And there are very handful of them. If I were to make long story short, pretty much everything in embedded system is a state machine. So learn how to write better state machines. And one more thing is usually there will be a constraint involved. So much like how in the software side, there would be like a memory access or speed versus time kind of a thing. Here it would be speed, time, and power. So you can optimize only for maybe one or two, but not all three. Long story short, they should be looking for design patterns and improving their ability to write better state machines.
Yeah. The things that you have said, like power is also like important. Like what I am saying,
Yes.
like I have done a little research on this, and from that,
Hmm.
what I observed, like AI requires lots of computation. Any hardware, like any embedded system kind of machine, they are designed for power efficiency. So these two are
Yes.
not matching, and that's why we are not able to. I may be wrong, but this is what I
Hmm.
understood after reading some article. So, what is your view
Sure.
on that?
Okay. So what I'll first like to call out is there are two things in AI. One is called the training. The second one is called the inference. So inference can be a much low power affair compared to training. Because
Okay.
for training, you're running back propagation and complicated algorithms, and you need power for that. That's why, the data centers consume so much power, and OpenAI is kind of, going after funding of billions of, well, 500 billions and whatnot. When it comes to inference, the complexity of inference dictates how much power you're going to burn. So, for example, you can run a face recognition, human or not human, face or not human kind of a algorithm on Arduino. That is possible, and Arduino can run that. What you cannot run is something like, let's say, what Tesla does. Figure out the car. Is it a car? Now, is it a dog? Should I run over a dog? Should I not run over? Those kind of things take a lot of power. So few of the use cases that are already coming around are in our, mobile devices. The Magic Eraser, for example, which is on Apple and I think also on Google phones. So you're able to kind of, erase out certain thing out of a picture. So that is an AI application completely driven at the hardware level. Then, in the cameras we have, for example, on my system, I'll just briefly turn it on as an example. So we have this live blur, right? That is also to some degree now AI driven. And then each laptop or phone now also has this noise cancellation feature. Earlier, it used to be signal processing based. Now it's more and more AI based. It guesses as to what was the human voice and what is not. So that is what it is. Power definitely is a huge concern, but depends on the use case.
Yeah, looking forward more improvement in
Sure, sure,
robotics kind of field. Yeah,
sure,
so and I just want to
sure.
ask, like, can you share some like interesting things that is happening in AI industry that's very underrated? Like, we are like very hyped with OpenAI, DeepSeek, and many things, but something that is
Right.
happened due to the AI and that is very underrated.
Okay, so the crazy part that I'm aware of in the AI world is there are companies and they are going after creating biological neural nets to which you can deploy problems, right? So what happens there is, so in the digital world, we are going to do multiplication, addition, and all of that and come up with an answer. In case of biology, it's analog. So it's way, way faster. So that is one thing, I don't know full details of it, but I know there are some people who are going after that. So yeah, training algae is to become AI, for example. Yeah. It's
Something
that
like
weird,
training an
yes.
insect to clean the like sea waste or plastic.
Oh yeah, true, true,
Yeah, we
true.
can like this is
I'll
very interesting. We can train like this algae and all to eat the plastic,
true,
and this will
true.
reduce the sea plastic and
Yeah,
all.
yeah, yeah, yeah. Sure, sure. Why not? Why not? I'm pretty sure few people are thinking in that department. I'll give you one more example that I came across many years ago. This was a Cornell professor of biomedical engineering explaining that there are few people at Cornell who were trying to put a chip in a fly's brain and trying to control it. Yeah, it's that bizarre. I have no more details than this about
There's
this,
very
but
less research in biology side. Like if you will see, in last 30 year or 25 year, there's huge improvement in the software side, AI or like tech side, silicon side. But there is very less
yes.
research and development in like in the biological side.
Well,
Yeah.
thankfully, I have a friend whose wife is a doctor, so I got to learn a lot from her through her stories. What I feel is the research is going on there as well. For example, Dr. David Sinclair, for example, he's working on how to reverse the age, right? There are people who are, yeah, working on medicines that can be at,
15%. Brian
yeah,
Johnson, something
yes.
like this.
So he's
Yeah.
also there.
He have spent like around like millions of dollars for this kind of
Yes,
research.
yes. So what is happening is the research in biology is it's very hard for them to glorify and broadcast it. And people like us go, see, for computer people, CS and IT people, it's very easy to share what they have learned because they are the ones who built the internet, right? The
Correct.
biology guys have to first understand how to create a website, how to, record a video, edit a video, put it online, and then who's going to watch it? Because other biology people are in the lab.
There is
So
no LinkedIn for them.
exactly, exactly. So what ends up happening is there is a lot of research going on, but I think it's not available on the usual channels we follow, which is YouTube, Twitter, and all of that. Right? I think they pursue their development through journals and all of that. So definitely that's happening. I'm looking forward to medicines that are completely kind of, tailored to my DNA, for example. Someday they'll come, but someone's working on it. That I know.
Yeah,
Yeah.
so our journey will not stop for the AI
Yeah.
development only. There is lots of room for developing other domain also, like as you
Right.
can say, you just shared. So yeah, with this note, I want to end this video. It was a really good podcast. Thank you, Piyush, for accepting my invitation.
Thank you for having me. Wonderful talking to you, and thank you for having me. Yeah.
Okay, bye bye.